Hello and welcome for the SPSS modelers. So that is what we have today. Today we'll be discussing about the modeling nodes. So when we speak of modeling nodes, we had seen earlier also in many of our previous sessions that there are three typical combinations: supervised, unsupervised, and segmentation nodes, so supervised, association, and segmentation modeling nodes that are available. Each of these nodes, we have a list of additional nodes which are part of that particular collection of nodes. So fine, let's quickly start with the software itself. I'll type in here. Yes, SPSS modelers subscription. Right. Okay. So we are now launching or loading the software. Yes, there it comes. Initializing helpers. Hello, Azure. Hello. Right. The software is now launched and ready. We do not need this window, so I'm going to close this window. Do not intend to launch any of the existing file streams. Right. So okay, well, let us do one thing. Okay, we click on the modeling node here. As you can see, out here we saw there are three dominant types of modeling nodes. The first of them is the supervised, and then followed by association, and then the segmentation. Now we can see the association and the segmentation nodes are what, 5 and 4 respectively. But the supervised modeling nodes is quite a long list, starting from random trees to tree AAS, CNR tree, that is card tree modeling, which is part of the decision trees, of course. And then we have the decision list model. We have the automatic linear modeling model, predictive linear regression, and then we have the principal components analysis, neural networks, and the list and the nodes go on and on until STP, which is a spatio-temporal prediction model, and then it's preceded by TCM, Quest, Child, and KNN, its K nearest neighbor model. So with all these modeling nodes in place, let us start with implementing these modeling nodes. But prior to that, as we are discussing on the course contents, we'll be taking an overview of all the modeling nodes and their types. That's what we just happen to see: supervised, association, and the segmentation node. And then thereafter, we also saw modeling node fields and analyze options, and yeah, the model nuggets, of course, because in case of many of the modeling nodes, typically regression types or decision making types, or the TCM. So I mean, irrespective of segmentation or association of supervised modes, there is always a chance that you'll be getting model nuggets as an output. And then we also have the statistical models, which are advanced output. And then finally, we will also be taking a look at neural networks. Now, neural networks is interesting because, but then out here, in case of IBM modeler, it generally throws out the multi-layer perceptron model of the neural network. We'll look into it, whether it's multi-layer or single-layer perceptron also. But then, yes, this is what we have for the modeling nodes. And right, so fine, let's minimize the screen. I'll come back on the software itself. And so let us quickly open a stream. Now we already have a stream open over here, but I don't want that. So I'm going to right click on it and scroll on and click on close stream. Now, right, yeah, let's open an existing stream. And we were already working on one of the streams yesterday. So I'll go back to that stream again. Yes, we were working on the housing price index stream. So let's open the stream. So you can either click insert or you can click open. Either ways, it's fine. So I'm clicking open. Right. So that is a stream that we have. And out here, yesterday, what all did we do? Yeah, we were discussing yesterday about working with outputs, and we were working with viewers and all, and pivot tables and options as well. And as part of this exercise, of course, we were supposed to have the output nodes connected to the source node, as you can see here. And then we also saw these nuggets coming out and all. So if we want to carry, we can carry on with this also. So fine. Or let us do one thing. Let us open a fresh stream altogether. We'll take a fresh data set. I'm closing the stream. Let's click on source node here. Let's open a fresh stream here. Okay. So unless you open the stream, this will not come up. This will not get activated. Right. So I'll click on MS Excel. Right click on that. Click on edit. And now I'll go and I'll import the file. Okay, we don't have anything here, so we have to look at the data set that we have generated. We have 8 fruits. Yeah, data set. So let's open this. Right. I click apply and I click OK. Right. So we have imported the date fruit data set. Now that's agriculture example that I have taken. So, but then on that example, we'll see which kind of nodes will be trying to apply. And if not this, then we'll pick some other node as well, which will give us a certain kind of fitment on the modeling nodes that we intend to perform the analysis upon. And if not this, there are many other examples also that we can take. Fine. So right click on that, click on edit. Yes, we have done all this already. Now these are the big chunk of filters that are available. So now let's try and get rid of many of most of these. See, we don't want the means. Those standard deviations are also required. Typically, these are the outputs that were already generated. So I'm getting rid of all of them. Entropy, RG, all of 4RR class. Let us retain class. That is important. Yeah, we don't need entropies either. So what I'm doing here is I'm retaining area, perimeter, major axis, minor axis, eccentricity. Let us do one thing. Let us get rid of these as well. Major axis, minor axis, convex area, extent, aspect ratio, roundness, compactness is important. Shape factor, I don't need. So fine, I'm not taking a very big list of attributes and parameters to keep things simple for us. Click on types and let us click on read values because out here the values are missing. So if we import this without reading in the values, then it'll throw up an error, of course. So I click on read values here. Select OK to read all the values for a field. Select cancel to return. I click OK. Fine. So these are the set of values that are evident here. And what is missing? Nothing is missing. So I'll leave it at that. There is nothing missing. So let's cancel it. And right, I click apply and I click OK. So the source node is ready. Now, fine. So do we need anything on the record ops or field ops just in case? Let us click on auto data preparation. We have not used field ops or record ops, so we'll use one of these to add some more work or task to our output. So let us right click on this and click on run from here. There are no executable nodes, of course, as it was on anticipated lines. Never mind. So let's click on edit and let's see what all preparation they have done. So that is the objectives. Automated data preparation can recommend data preparation steps. Blah blah blah. Okay, so it is interesting. I mean, it automates your work. So it is always desired and suggested and recommended to use the auto data preparation field. Now, for the fields, we are not setting any target options, okay, but still if you want, we can set class as target options. And for the inputs, let us select the roundness, compactness, roundness, compactness, aspect ratio, eccentricity, solidity. We can, it's okay, we need not take aspect ratio. I click apply, I click OK. Then what are the settings? We are sticking with the default settings. Analysis, no model is available yet. Annotations I don't want. And then I click on analyze data. Is there any analysis that has been generated? Not that I see also. Let's analyze data again. Okay, there is a clear analysis generated. So let's click apply and I click OK. So fine, the auto data is now prepared, complete. So now let us go on the modeling nodes here. And of course, in a given data set, we do not have any of the status values. So let us see which of these nodes will be select. So let us select something that's a little more simpler for now. So I click on linear and I drag it over here, drop it here. Right click here, I'll click connect and I'll connect auto data prep with the linear mode. Now there are no targets here. So let us set the targets. And again, once again, once the target is set here, then this file name from no targets will change to some file name. So we take custom assignment. What is the target that we want to check? Just check the aspect ratio. So that's your target. And predictors are what? We are taking all the transformed variables. Okay. Okay. And is there an analysis weight? No, we don't have any analysis weight. What are the build options that we have here? Build a new model. Of course, what do you want to do? You want to build a new model. What is your main objective? Create a standard model, of course. And the basics automatically prepares the data. That is something that we already carried out by adding this auto data preparation node. So that will be taken care. And model selection. Now we are selecting the default settings that they have. And after that, what are the symbols? Yes, sticking with the same default setting. Advanced generate. What is the random seed? No, that's a huge number. You can avoid it, ignore this. Model options, model name is automatic. If you want, you can add anything, but that's fine. Leaving annotations as is. And the objective you can see here, that is a standard model that they have selected, that they want to have as an objective. I click apply and I click OK. See, now you can see here the aspect ratio. Why is it naming it as an aspect ratio? Because aspect ratio is what we have set as a target variable. So every time you set a target variable, that target variable will the modeling node will take that as a node name for that. Fine. So and out here, let's click run. We can click run here also, or we can click on this on the source node here and click run from here. So you can see everything is in green. Yes. Now, what is that? That is your model nugget, as we call it. Where were we? Yes. So what do you see here again? The modeling and the node that you're seeing, overview of the modeling node. This is something that we've done. Modeling node field and analyze options. We checked that as well. And then we generated the model nuggets. How? That is what we did. After we ran this particular stream, we generated the model nugget. Let's right click on this and save the stream as what? Be saving this as part of live sessions, SPSS modeler, day 8. No, it's day 8, right? Yes. And yeah, fine. So let's put this as date fruit. That's the file name. I'm clicking on save. Now that's a stream file. Okay, so it's .str extension that has been saved in day 8 of the given folder, and I click save. Now that we have this output generated, let us view the data here. Although most likely it will be the same data that we have seen. Aha, now that's the data from aspect ratio node. Yeah, now that is the data that was already that we had selected. The class transform is 0. No, that is a class transform that we are seeing here. So depending upon the variables that we have, the classes have been allocated in accordance, depending upon the values. So and what do we see here? We can see here, oops, where is it gone? Right, what do we see here? The aspect ratio, there is a sign over here. Okay, if I click on that. Yeah. Fine, so this is what we have as far as viewing data is concerned. You can also create a chart and graph and all that, but I'm not going to go into that as yet. Not interested for that. That is not the objective of our today's live session either. So we employed an modeling node, and we generated its model nugget. What's the next thing that we intend to do? We also intend to generate the statistical models advanced output. Now, when we speak of statistical models advanced output, what is that supposed to mean? Let's click on output. Now, we can select any of these values here or any of the nodes here to generate some kind of meaningful output. So let us select transform. Well, let's have it this way. If I run, right, click on this and I click run from here, no fields have been specified. Of course, we have not. So click on transform, click on edit. Now we understand it better, right? That we have to define the attributes and parameters in and across the nodes, irrespective of, I mean, without that, it is not going to work. Meaning there has to be some field which has to be identified for any stream to run. So again, I'm selecting aspect ratio over here and I click apply and I click OK. And, what are the options? Selected formula. We are leaving everything as is. Click apply and I click OK. So we can see it's showing us one field. So right click on this and let's scroll down and select run from here. Right. So what do we see here? For aspect ratio, these are the outputs that have been generated, the transform outputs that have been generated. Now that's select a transformation, current distribution, inverse, log normal, and log 10, exponential, square root. So let's open square root, any random output that we can. So what do we see here? The aspect ratio that we are seeing here is 1.3887, count of 897. So that is the histogram of the aspect ratio square root. If we take the exponential value of that, yeah, that is 6.07 e raised to minus 30, and the count is what 897. So these are the different expense ratio values that we are seeing for these distributions, and that is evident over here, and that is the output that is getting generated. Fine, so let's come and save this. Transform our distributions. Now, the interpretive part is I'm leaving it for you all to work upon. If you click on inverse, so out here we can see there is perfect normal distribution type structure, the bell shape, but it is fine. That is how your graph is showing up here. Yes, if you want to split in bands, that is also possible. If you don't want to split in band, that is also there. So split in bands are formed with 3 equals. Let's click on split. Yes, so we are seeing first, second, and the third band. So in the third band, we are seeing that the bell shape is peaking at the third band. And its aspect ratio, notice aspect ratio is 0.6516. Then increase the split. I click split. So there'll be 8 bands out here. 1, 2, 3, 4, 5, 6, 7, 8. So again, what is the significance of these bands? Well, they help us in working on particular band or particular section in that band. So this is how it is. And I click OK. So that is the output that we generated by using the modeling nodes. So I click OK. I'm closing. Yeah, I click OK here. And this is now completed. So this is how we conduct the modeling outputs analysis. We are yet to work on the neural networks aspect of that. So let us do one thing. Let us check out the data sets that we have. Let's check on statue images, data set features. If this we have very healthy count of values whereby we can That's the Kirimizi pistachio. That is a class of pistachio. You don't need the shape factors. I can delete it. What more do I need? The area parameter minor. Yeah, major minor. I click delete it. Can we have PDIS Q? No, I don't need that either. I'm retaining solidity. Extent and yes. So fine. Now 1, 2, 3, 4, 5, 6. 6 of these are your variables, and I'm saving this as live session. Today is day 8. Fine, let's save it over here. We are saving it as an Excel file. Hopefully this is an Excel file. If not, let's check it again. Yeah, it's an Excel workbook file. So I click save, place it. Yes, I'm closing this window. Let's go back to the software, and I'll open another stream here, which will be for Kirimizi pistachio. So let's click on another stream here, and I'm renaming the stream as what? Save as. Yeah, that is your file stream name. I click save. And so now that is set. Now let us work on the neural networks aspect. So again, I'll go to the source. I click on Excel, right click. I scroll down and click on, yeah, okay, you scroll up and click on edit. I'll import the file here by clicking on these 3 buttons here. And we have the pistachio data set. I click open. What are the filters? We are not taking any filters as such. So let's retain all of them. Types, yes, we are having, let us read the values. Let us have the default reading by the SPSS modeler itself to avoid any errors. And refresh it. Yes. I click apply, and then I come here and I click on OK. Fine. So with this pistachio Excel data set, we'll now associate the modeling node. That is the modeling node. We are selecting supervised node only, of course. There is nothing on the association nodes that we can take on the segmentation, although we can take 2-step AS segmentation. We'll see in a later part of this session if you can pick one of these 2-step AS. Okay, means AS segmentation. Meanwhile, sticking on supervised, let us click on neural network. So that is the node that we have selected. Now out here you can see there is no targets again. So unless you select a target in a modeling node, it will always show you that there are no targets. So fine, right click on that, click on edit, and use custom field assignments. Yes. Now, what do you want to really study about? I want to study about the aspect ratio. So I'm setting that as a target, and I'm selecting the rest of them: eccentricity, solidity, roundness, compactness, and extent as predictors. Apply. Let's check on the build options. We are building a new model, of course. And then what is your main objective? Is to create a standard model. So that is the honest main objective. I click on basics. That's a multi-layer perceptron. Can we select a radial basis function? No, I'm not going on all that. I'm sticking with multi-layer perceptron. Stopping rules, minutes is maximum programming time. Training time is what they are putting 15 minutes. Now let's see if it's going to last 15 minutes. Customize the number of maximum training cycle, minimum accuracy, ensembles, voting mean. And then you click on advanced. So overfill prevention set is about 30%. Now, these are the default settings that these people have, that the software has. So we're going to stick with them. What are the model options? Well, we'll be calculating the predictor importance. That is important. That is important. And once we have the output, then I'll explain why is it important. Automatic and the custom model name. Yes, selecting the automatic name. Probability of the predicted value. Increase in probability from next to most likely value. So fine. We are setting these as the defaults. I click apply. I click OK. So yeah, as you can see here from no targets, we now have aspect ratio as the desired target. Now, since this is a modeling node, if we try to run this, most likely it might throw an error that you do not have an output node. So let us not be worried of that for now. I just want to click on statue and I click run from here. Yes, now it's running. Now see, we can see here that there is a model nugget generated. It is not throwing any error. Why? Because a modeling node will generate a model nugget. But when it comes to eventually the output in terms of table or matrix analysis or the whole bunch of outputs that they are generating, we will need to have an output node to the nugget at least. So fine, let us right click on nugget and see what it has to offer. See, what do we see here? This is interesting. Out here, we can see, yes, now that's the window. We see the model summary. It is a multi-layer perceptron. That is something that we had selected. Stopping rule error cannot be further decreased. Hidden layer 1 neuron. How many hidden layers are there? 2. Fine. So let's come here and see it. Yes, see there are two neurons. Okay, 1, 2, 3, 4, 5, 6, and there are 2 neurons. So hidden layers are 2. Again, there are only 2 hidden layers, meaning it's not 2 by 2 or 2 by 3 types. And then there is a bias that is added, and then it eventually culminates into the aspect ratio. This is the extent. If you want to click on top bottom approach, there. If you click on bottoms top approach, there it is. Effects what? These are stylist effects. If you want, we can add the coefficients also. I would rather prefer coefficients, but the values are not showing up over here. And let's have it this way. Oops. So negative to positive. So we can see eccentricity is highly negative, and then the element of bias is highly positive, followed by the bias and neuron true over here. The rest of them are reasonable values in terms of the coefficient cell sign. And let's click on preview. So that is the output, not output, that is the data set content that they are showing us. We don't need it anyway, so I'm clicking OK. Then I click on generate. What can we do here? Well, we can generate a modeling node, we can model a palette. Field selections are also possible. Right, so this was only the first part of this. The next part is the model. That was only the model summary. That is a predictive model. So that's what the thing is here. See, we see eccentricity at 0.81, compactness at 0.15, solidity, roundness, and extent. Extent is like hardly any relevance because its importance is 0. If I come back here on this node, what do we see? Eccentricity has the highest synaptic weight estimate. I mean, on the negative side, it's minus 0.7. That is what we are seeing here also, that this predictor has greater importance compared to compactness, solidity, roundness, and extent. Again, if I come back here and see it for compactness, solidity, and roundness, these are like, in terms of synaptic weight estimate, they are in between types. They are neither highly negative or they are neither highly positive. So those values, the level of positivity or negativity, will be applicable or available in the predictive importance page. That is 0.15 and 0.03, and roundness is how much? 0, and extent is also negative. No, that is also a 0. And this is what? This is the predicted value that is observed. So we can see that is upward trend out here on the predicted value, and equally on the aspect ratio. So this is how your model nugget or the model for the neural network is generated. But that's not an end in itself. Let's click apply and I click OK. Now, after this is generated, let us go to the output modes and see what more can be done about it. So let us select the analysis out here and see how will this node react with the model nugget. Right click and I click view data, click run. Yes, now what is that? That is the analysis that it generated. So comparing neural network aspect ratio is aspect ratio. The minimum error is this, maximum error is this. These are the different outputs that are generated, results for the output field for aspect ratio. Let's save this. This is interesting. Mm. So that is the output. That is the report that has been generated. What more do we have here? Annotations, nothing. Click on edit file. It's much the same. You can export this as an XPS, HTML, or a text format. So what do we see here? The mean absolute error, MAE is 0.006, mean error is 0, standard deviation is 0.01. So it's relatively stable at only 1% variability. And then we have the linear correlation at 0.99. So that's 100% correlation. Occurrences are 2148. So 2148 means what? Those are the number of counts that are available to us, or number of observations, N as we call it. I click OK. I'm saving the stream, of course. So in outputs, we have selected all different histograms and the analysis.